Okay, so on to question 4. Question 4, find the angle x in the triangle below. Little bit of a tricky here. It's an isosceles triangle, but it's not a right angle triangle. So I'm going to make a right angle triangle by cutting it in half. Because it's isosceles, we know that will be exactly in half. So that's now a right angle. This side's 6 centimetres because this side will be 6. That side's 6. Whole length will be 12. That only works because it's isosceles. Because it's isosceles, if I cut it in half, I'll get 2 exactly congruent triangles. So I'm trying to find x. I currently have an A and I have a hypotenuse. A and H is K. A goes on the top, H on the bottom. So cos is a -1. A on the top, 6. H on the bottom, 9. Put that in my calculator. Shift cos 6 divided by 9, 48.2 degrees. Job done. Question 5. Rope 10 metres long, top of a vertical pole makes an angle on the ground of 23 degrees. How high is the pole? So I've got a rope which is 10 metres. I've got a vertical pole, so that means at right angles to the floor. Angle of 23 degrees. Now second, a rope of 10 metres long from the top of a vertical pole to a point on the ground makes an angle of 23 degrees with the pole. So I'm making that angle with the pole, that's what I was checking. Not with the floor, I'm making an angle with the pole, quite important. How far off the pole? So that's what I'm trying to find. So this side's the H, this side's the adjacent. A and H, and I'm looking for the A. So I'm looking for the A, I've got the H. I'm looking for the A, so that's what I'm looking for. I know the H, so C times H. C stands for cos, the angle is 23, times H, H is 10 metres. In my calculator, cos of 23 times 10 is 9.2. So 9.2 metres up the pole. Okay, let's see if I've got time to do the very last one. So very, very complicated 3D diagram. All this information based tells us that that is the correct diagram. Right, calculate the size of the angle that the line DE makes with the plane ABCD. So I'm trying to find this angle here that they've quite nicely drawn on there. In an exam, they would not give you this much kind of drawn on. You'd have to kind of construct it yourself, but because of this, I give you a bit of an easy one where it's constructed. Right, so to do this, first of all, do I know the distance from E to B? No, so I want to calculate that, aren't I? So I need to know this length. I also need to know this diagonal length across the floor, because if I know this diagonal length across the floor and I know this one, I can then use those two sides to find this angle. So I'm going to draw out a few things that I need to find. So the first thing I need to find is this E to B. That is 30 degrees. That is 60 centimetres in A. So first I want to find this one. Then I'm going to use this triangle on the floor, the DAB triangle. So on the floor, remember it tells us these are all rectangles, so we know the right angle to corners. So A, B, D, we know it's a right angle. Because the fact that we know the bases are rectangles, that must be a right angle. That is 60 by 60, and I'm going to try and find this side. And then lastly, once we've done all that, I'm going to take out this triangle here in the middle. So that triangle there in the middle is going to go D to B to E. Right angle, because it says it isn't, because in this right up it tells us all the things are rectangles and squares. And this is the angle we're looking for. So we don't actually know anything about this triangle yet, but hopefully if we find B to D here, that'll fill in there. And if we try and find E to B here, that'll fill in one there. So E to B here. This is the adjacent, this is the opposite. A and O means I've got toa, toa. I'm trying to find the O. So I've got T times A. So the angle is 30, tan 30 times A is 60. Let's work that as an answer. Tan 30 times 60. I'll just get my calculator as a bracket. 34.6. 34.6 centimetres. That is E to B. So on this diagram, E to B, I found that is 34.6 centimetres. So that's that measurement there that I found. Right, I'm now going to try and find this big long diagonal by using this triangle. This I've got no angles in. I've got two sides now on another side. That makes it Pythagoras, a little bit easier. So this is the long side, so that's C. So I've got A, add B. So I want 60 squared, add 60 squared equals y squared. Use my calculator quickly. 60 squared, add 60 squared is 7,200. So to get y, I square root that. So square root the answer, 84.9. That is the length B to D. So on here, that is the length B to D. 84.9. Show in the top diagram, that's that length there. So I've now got this length here, and I've got the height. So now I know 2, so I can find this angle. So because I know 2, I can find the angle. So for this angle, this is the opposite, this is the adjacent. O and A again, so that's another tan one. O, A. I know the O and the A, I'm looking for the angle. So I'm looking for the T, I'm looking for the angle. So tan to the -1. Remember, these orders matter. O on the top, A on the bottom. So 34.6 on the top, 84.9 on the bottom. Let's pop that in my calculator. Shift tan, 34.6 divided by 84.9 equals an angle of 22.2 degrees. All done. If you need any more help, send me a chat. Thank you very much. Have a lovely holiday.